Welcome back to 1200 plus PYQ series of CSIR NET examination. This question was asked in NET December 2014. The question says that if the binding energy B of a nucleus having mass number A and charge Z is given by B is equals to ABA minus ASA to the power 2 by 3 minus as by m 2z minus a whole square by a plus ac z square by a to the power 1 by 3. Okay, then find the formula for the most stable isobar. That is, here we have to find the atomic number for the most stable isobar by using the formula of binding energy, provided that the terms AC, which is Coulombic energy term, ASYM, which is asymmetric energy term, AS surface energy term, and AB is the volume energy term. Here in the question it is provided that your Coulombic energy term is 0.7 and your asymmetric energy term is 22.5, and hence by using this formula just find what is the formula for the most stable isobar and then find the atomic number for the most stable isobar. That is, here your options are A is equal to 68, B equal to 72, and your C option is equal to 84 and D option equal to 92. Okay, so which is correct? So let us now solve this question. Okay, for the most stable isobar you have a direct formula when you have given with binding energy and you have to find the most stable isobar. Then this is the direct formula for it. Okay, there is a derivation of this formula. What you can do, you can just simply differentiate this binding energy. If you will simply differentiate this binding energy, that is del B by del Z, and put equal to 0, then you are getting this formula. Okay, you will get this formula. So now let us solve it. Okay, so here written the direct formula, that is given as Z is equal to Z naught, which is equal to A by 2 plus A coulombic by 2 asymmetric A to the power 2 by 3, where A is your mass number. Okay, here is a mass number. A coulombic, that is AC, is the coulombic energy term. AA, that is A asymmetric, which is the asymmetric energy term. Okay, now in the given question, okay, in the given question you are provided that your mass number A is equal to 216. In the question it was written that the mass number A is 216, your coulombic energy term is 0.7 and your asymmetric energy term is 22.5. So in the question it is given that mass number A is equal to 216. Okay, mass number A equal to 216, your coulombic energy term is equal to 0.7 and your asymmetric energy term is equal to 22.5. So let us now solve this. Okay, so first what you will do, you will write 216 in place of A, and A coulombic in place you write 0.7, asymmetric you place right 22.5. Okay, so now let us solve. That is, Z is equal to Z naught is equal to 216 by 2 plus 0.015 multiplied with 216 power 2 by 3. If you solve, that is 0.7 divided by 2 times 22.5, then you are getting 0.015. So now we will simplify it. Okay, this will be simplified now. So now it is 216 by 2 plus 0.56. If you will solve this, that is 216 to the power 2 by 3 in the calculator, then we are getting some value. If you multiply that value with 0.015, then you are getting 0.056. Okay, in the CSIR NET examination you have a virtual calculator on your computer screen. In that screen you can just put all these data and just solve the value easily. Okay, you don't need to do manual calculation in your examination. Okay, so now what we got that Z is equal to Z not equal to 216 upon 2 plus 0.56, that is z is equal to z0 is equal to 216 by 2.56, okay, which is comes to around 84, okay. Hence we are getting from the direct formula, that is z is equal to z0, which is equal to a by 2 plus a coulombic by 2 asymmetric a to the power 2 by 3. If you will put all this value in this, okay, just remember this formula, then what we are getting, you are getting 84 as the answer. So let's check, is there any option which is saying 84? Okay, let's check. Okay, so yes, c is telling 84, hence c is the correct option, okay. If you are liking this video, if anyhow this video seems helpful to you, then please subscribe my channel Researcher Rohan Physics. Thank you, have a nice day.